G'day everyone and welcome back. In this video we're going to set up a first-person interaction system. This topic will be broken up into two videos. In part 1 we're going to build the foundations of the system so that we can design our interactions using code. And then in part 2 we're going to improve the usability of our system by including a way to use Unity events when designing our interactions. Before we begin, I'd like to let you all know that I've set up a Discord server for anyone who wants help with the topics covered in these videos, or any other kind of game dev help as well. It's still evolving as I figure out the best way to use the platform, but there's already a number of super nice and helpful people in the Discord. There's a link in the description if you want to check that out. Back in the Unity project we created in part 1, I've got two rooms here separated by a door. On one side of the door we've got our player, and on the other side of the door we have a cake. Our goal for this video is to get this door open and get our player to the cake. So we'll start by heading into our scripts folder and creating a new C# script called interactable. We'll open this up. And the first thing we want to do here is make this a public abstract class. So this is going to be a template for us to create subclasses which will gain all of the functionality of this interactable script. Whether it's a button or a door, a health pack or an elephant, if we want the player to interact with it, then it will need a script that inherits from interactable. Now let's add a public string, and we'll call this prompt message. And this is going to be a message that is displayed to the player when they're looking at an interactable. Now we can get rid of start and update and replace that with a protected virtual void function called interact. Now we won't have any code written in this function. This is just a template function to be overridden by our subclasses. Now just above that we want to create a new public void function called base interact. Inside here we want to call our interact function, and this base interact function will be called from our player script. Now this all might seem a little bit confusing, but what we've done here is something called the template method pattern. I've got a link in the description if you want to learn a little bit more about this. So now we'll save that, we'll head back into Unity, and we'll create a new C# script called player interact. This script will contain all of the logic to detect interactables and handle our player's input. So we'll drag this onto our player now, and we'll open it up in our editor. Now the first thing we want to do here is have a reference to our camera. So private camera, and we'll just call this cam. And because we already have our camera on the player look script, which is attached to the same game object, we can just assign this in start to cam equals get component player look dot cam. Now in order for us to detect interactables, we're going to use a Raycast. There are three parts that are needed to perform a Raycast. The first part is the Ray variable. All a Ray has is an origin and a direction. It's essentially an invisible line that will detect colliders. The second part is a Raycast hit variable, which we use to store some information about the collision, such as the distance from the origin and some of the components of the hit game object, like the transform, rigid body, and collider. And the final part is the Raycast function, and this is what we use to actually check for collisions along the ray. So now in update, let's create a new ray, and we'll call this ray with a lowercase r. This is equal to a new ray. The first parameter is the origin, so we want the origin to be the camera.transform.position, and the second parameter is the direction, so camera.transform.forward. So this has created a ray that will shoot with an infinite distance, but we can control how far we want to draw this ray and how far we want it to check for collisions. So up the top, let's create a new private float, and we'll call this distance, and we'll set this to equal 3. And we also want to serialize this so that it's visible in the inspector. Now we can debug our ray by typing debug.drawRay. We'll pass in the ray.origin and the ray.direction, and we'll multiply this by distance. So we'll save that, we'll head back into Unity. And now if we go look at our player and we test this out, we can see that we're drawing a ray from the center of the camera, and we can control the distance of how far that ray will shoot. Alrighty, so back in the script, we'll create a variable to store our Raycast hit, and we'll call this hit info. And the last step is to use the Raycast function to check if we've actually hit anything. So we'll type physics.raycast, and in here the first parameter we'll pass is the ray that we just created. And for the second parameter we'll type in out hit info. And this out keyword means that the function is going to return something here. In this case, it is a Raycast hit. So when we type this, we are actually assigning a value to our hit info variable. And then the next parameter is our distance. And then the last parameter will be a layer mask. So up the top, we'll create a new private layer mask. We'll just call this mask. We'll serialize that. And then we'll pass it into our Raycast function. Now, the handy thing about the Raycast function is that it will return a Boolean. So we can wrap this whole function inside of an if statement so that all of the code inside the block here will only run if our Raycast hits something. So we'll save that, we'll head back into Unity and we'll create a new layer for our interactables. Up in the top right of the inspector, we'll go to layer and we'll add a new layer. I'll use layer 6 and I'll type in interactable. Now in my scene, I've got a cube here, which is a poor representation for a keypad, but let's just use our imagination. And we'll assign it to the layer interactable. Now we can click on our player game object and we've got a drop down menu with all of our different layers on here. So we want our Raycast to be checking the interactable layer, so we can select that one there. Awesome, now back in the script, the last thing we want to do here is check if the game object actually has an interactable component on it. So if hit info, and keeping in mind this isn't the game object itself, it's just some information about the collision. So we'll get the collider dot get component interactable is not equal to null. Then we can debug the hit info dot collider dot get component interactable dot prompt message. Alrighty, so we've made our base interactable script and we've given the player a way to detect those scripts, but they're still a way off from getting their cake. So now let's get the keypad working. We'll save that, head back into Unity, and we'll create a new folder called interactables. In this folder, we're going to put all of our scripts that inherit from the base class, like our keypads and elephants. So we'll create a new C# script called Keypad. We'll drag it onto our Keypad game object and we'll pop it into our interactables folder. Now we'll open up the script. And first up, we want to inherit from interactable. We could probably get rid of start and update here, but I'll just leave them in case we need them. And down the bottom of the script, we'll type protected, override, and we want to override the interact function. And this function is where we will design our interaction using code. If we want to change colors of something, play an animation, destroy an object, then we will do it in here. All I'm going to do for now is just debug a message saying interacted with plus gameObject.name. Alrighty, so if we head back into Unity and look at our keypad in the inspector, we can see that this is now inheriting the prompt message. We don't actually have a variable for this on our keypad class. We're getting that from our interactable class. So I'm going to set this to use keypad and I'll hit play. If we walk up to the keypad, we get a debug message saying use keypad. So our next step is to display the message on screen. Using text is a nice and clear way of giving feedback to the player, but there's lots of different ways that we could do this. We could update the crosshair, display a button prompt, outline the object, and you may have noticed a lot of games will display their prompts in world space, where the text hovers around the object itself. If there's any interest on how to set up world space prompts or any other types of feedback, I might create a video for that later on in the series. But for now, let's just stick to displaying prompts in the center of the screen. So over in the hierarchy, we'll go create UI, and we'll create a new text mesh. I'm going to be using Text Mesh Pro, and if you don't have that installed, you can install it using the package manager, or you can just use the built-in Unity text. I prefer Text Mesh as it's a lot cleaner and has a bunch more options. So we'll rename this to prompt text. So Unity has parented our prompt text under a canvas, and it's also added another game object in the hierarchy called event system. On here, we've got a standalone input module, which allows us to navigate UI. However, we've got this big red stop sign here. And what all of this text here is saying is that this component is designed for the old input manager. So thankfully, Unity provides us with a nice way to fix this. We'll click this button here, and this will replace the component with one that is compatible with the new input system. Now, Unity has linked an example action asset that comes imported with the input system. So if we click on it, we'll see that it's buried in the packages folder, and it's kind of annoying to get to. So in order to keep things a bit more organized, we're going to take all of the UI actions from this asset and copy them into our player input asset that we made in the last video. So we'll right click, we'll copy, go over into our player input actions, then right click on our on foot action, and we'll paste it in there. Now we can close the default input actions, and before we do anything else, make sure that we save the asset. Now we'll navigate over to our input folder, and we'll click on the event system, and we can drag our player input asset over here onto the event system. And that will keep all of these bindings here linked. If you didn't save the asset before dragging this file on, then all of these would be cleared out and you would have to manually assign each one. So in our UI action map, there's some things in this asset that we don't need and some things that we might need to add. But for now, this will do the job. Now, before I forget, I'm just going to set the text to be in the lower third of the center of the screen. And then I'm going to set the alignment to be center as well. Alrighty, and let's create a crosshair. So we'll go create UI, image. We'll call this crosshair. Set it to be 0 on the X and the Y axis. We'll give it a width and height of 5, and we'll set it to be just the circle. Heading back into the scripts folder, let's create a new script called player UI. We'll drag this onto our player. And in fact, we've probably got enough scripts here that we could create a new folder for all of our player scripts. So we'll drag all of those into there. Now let's open up our player UI script. At the top, we want to make sure that we're using TM Pro. And we'll create a private text mesh UGUI. And we'll call this prompt text. We'll put the serialized field header just above it. And we'll replace our update function with a public void update text. This function will take a string as the parameter, and we'll call this prompt message. Now in this function, we want to set prompt text.text to equal prompt message. Now we'll save that. We'll head back into our player interact script. We want to have a private property for our player UI script. We'll call this player UI, and we'll assign this in start. Player UI is equal to get component player UI. And if we head down into our update function, we can replace this debug.log with player UI.update text. And one final thing that we want to do is make sure that the message gets cleared when we're not looking at an interactable. So at the very top of update, we want to set player UI.update text to string.empty. Now we'll save that and head back into Unity, and we'll drag our prompt text onto our player UI. Now if we hit play, our message is cleared automatically, and if we go up and look at the keypad, we can see that it pops up with use keypad. So now the next step is to actually interact with it. So we'll stop playing, and over in our action editor, we'll open up our on foot action map. We'll create a new action by hitting the plus button, and we'll rename this to interact. I'm going to give this action 2 bindings. The first binding is going to be set to E on the keyboard, and the second binding is going to be set to button west on the gamepad. Remember to save our asset and head back into the player interact script, and we'll set up the player input for interaction. So we need a reference to our input manager, private input manager. We'll assign it in start. And then down in update, we want to add in if input manager .onFoot .interact.triggered, which works in the same way that input.getKeyDown works from the old input manager. So anytime our player changes the state of the interact action, then this .triggered callback will become true. Now we could type in hitinfo.collider.getComponent again, but we're going to be using this multiple times here. So let's store this in a temp variable. We'll create a new interactable. We'll just call this interactable is equal. Then we can just cut this section out here, paste it up the top. Now we've got direct access to our interactable component using this variable here. We can type in interactable.promptMessage instead. So a little bit sidetracked, but let's just recap. We're raycasting to the center of the screen. We're checking to see if our game object has an interactable component. If it does, then we're storing that interactable in a variable. And then we're updating our on-screen text. So back to when our player is triggering the interaction. Inside the if statement, we want to call interactable.baseInteract. And remember, inside this baseInteract function, we are then calling the interact function. So because the interactable object we're looking at is a keypad, this will then run the interact function in our keypad script. Okay, so that's all we need to do here. Let's save our script, head over into Unity and test it out. And now if we walk up to the keypad and interact with it, we get a debug message. Now that's a step in the right direction, but our player still doesn't have any cake. So our last step is to get the keypad to open the door. Let's quickly create the animations for the door now. We'll run through how the door is set up first. We've got two halves of the door here, and they're just cubes with box colliders. These two halves of the door are parented to a game object that we're going to be adding an animation to. So we'll go up to Window, Animation, and we'll open up the animation window. We'll dock it down here next to the console, and with the door selected, we'll hit this Create Animation button. We'll stick it in a new folder called Animations, and we'll call this Closed. Now to animate the door, we'll hit Add Property. We'll open up door 1 and door 2. We'll open up both the transforms for these, and we'll shift click on the plus buttons next to the position there. And we'll delete the keyframes at the end of the animation. Now we can click this arrow here and we'll go Create New Clip. We'll call this animation Open. We'll do the same thing, add property, door 1, door 2, transform, and add the positions. We'll delete the last keyframe. And here we want to hit the recording button and we want to open these doors. Alrighty, so those are our two animations. We've got closed and we've got open. Now we'll head up to Window, Animation, and we'll open up the Animator window. In here, we've got both of those animations that we just created. We've got our closed state and our open state. So we'll need a parameter to control the flow of these two states. So next to layers, we've got parameters, and we can add a new one by hitting the plus button up here, and we want to make a new bool. We'll call this isOpen. Now we can make transitions between these two states. So when transitioning to open, we want to check to see if the bool is true. And then when transitioning to closed, we want to check to see if it is false. Now we can select both of these and we want to untick has exit time. Now if we hit play, we can kind of get an idea of what's happening here. Right now we're playing the closed animation. And if we check this bool, the doors open and the player gets their very first sight of cake. But that's cheating, so we'll stop there. We'll head back into our keypad script. And at the top, we want to have a private game object for our door. And we'll add the serialized field header to that. And we want a private bool for door open. Now down in the interact function, we'll get rid of our debug message. And the first thing we want to do is toggle our door open variable. So door open is equal to not door open. So that'll just toggle between true and false. Next, we want to get the animator component on our door. So door.getComponent animator .setBool, and the first parameter we're going to pass in is the name of the boolean on the animator. So is open. And then the second is the value that we want to pass in. So we could just pass in true or false here, but we want to pass in door open. Awesome. So we'll save that. We'll head back into Unity. We'll make sure that we drag our door onto our Keypad script. And now if we test it out, so we'll walk over to the door, we get our message, use Keypad. If we press the E key, the door opens, and our player finally gets their cake. And that's everything that we're going to be covering in this video. Now the next step is to go off and create tons of interactables that will make our game worlds feel alive. I'll add the 3 scripts from the examples at the beginning of the video here. However, some of them will need a bit of setting up to work correctly, but that should be a good basis for everyone to get started. Thank you so much for watching. I hope you enjoyed. If you did, please consider liking and subscribing. In the next video, we're going to expand this system and incorporate the use of Unity events with our interactables. We will go into some basic editor scripting to keep our design nice and clean, so stay tuned for that one. Bye for now.